Hello students, so continuing with our video on mole concept and stoichiometry, we have come to the third part of it, which is based on percentage composition, empirical and molecular formula. So let us see the concepts which will be required to do the numericals of this part. First of all, it will start with finding the percentage of any element in a compound. How is that done? You will have to find the total weight of that element in one molecule of that compound. That mass will be written in the numerator part divided by the gram molecular weight of that compound and then multiplied with 100. Like for example, if I take calcium carbonate, so if I am looking for finding the percentage of calcium here, so this calcium has a atomic mass of 40. It is having only one molecule there. So in the total weight of that element, we will be writing 40 by the molecular mass of this compound calcium carbonate. If you find it out, for calcium it is 40 and then for carbon it is 12 and oxygen 16, 3 is a 48. You add it up, you will be getting it as 100 gram, and because you have to find in percentage, so you will be multiplying with 100 and this will give you coming as 40%. So this is the way wherever we will get to find the percentage of any element in its compound, this is the procedure we are going to follow. Now coming to how do we calculate the molecular formula from the empirical formula. But now what is empirical formula? Whenever we write a compound, the simplest form, the simplest ratio in terms of whole number of each element present in a compound gives you the empirical formula. So if you take a look at a compound, like for example C6H12O6, so this is not in the simplest form. Carbon is present as 6, hydrogen 12, oxygen is 6. So if I go to put them in terms of ratio of carbon, hydrogen and oxygen, so it will be written here 6 is to 12 is to 6. But this is not in a simplest ratio. You can see all of them can be divided by 6. So if I divide, it comes to this. Now if I use these numbers and write the formula there, so that is C1, H2 and O1. Now this is called as the empirical formula. So empirical formula is writing the formula of that compound but with each element written in the simplest ratio. So this table will help us in knowing the empirical formula. So what all things are there in this table? First column is for elements. So whichever elements are present here, like it is here carbon, hydrogen, oxygen, these will be written. Then the percentage composition will be given, that has to be written here. Then the atomic mass of that element will be filled up. Atomic ratio you will get by dividing whatever is the composition divided by the atomic mass. So that will give you the atomic ratio. Now once we know the atomic ratio, we will convert them into the simplest ratio and write there. Once we know the simplest ratio, like it was here, we can get into the empirical formula. Once we know the empirical formula, that ratio, like here it was divided by 2, that ratio value we can get, which we call it as N here, and that you will get dividing the molecular weight of that compound with the empirical formula weight. So the molecular weight of the compound will be given. Then what formula you get of the empirical one, you will find the empirical formula weight, divide it and get the value of N. And this N will ultimately help you in knowing the molecular formula by multiplying the empirical formula with N. Multiplying with N means here the subscript will be multiplied with N. So let us proceed now to work out the numerical. Now coming to the first one, which is simply a very easy numerical, just to write the empirical formula of the compounds which are given. Give the empirical formula of all these 4 of them. So we write the first one, C6H6. So you can see both are having 6, 6. So empirical formula means writing it in the simplest ratio. So both of them can be divided by 6, and so the empirical formula will become CH. Okay. Now coming to the next one, that is C6, H18 and O3. So the empirical formula of this will be, you can see 6, 18 and 3. So it means each of them will get divided by 3. So if you divide it by 3, you get C2, H6 and O. So that becomes the empirical formula of this compound. Then the next one is again a very easy one. So both of them can be divided by 2. So you get it as CH. Now let us see the next one, CH3, COOH. Now currently if you see, carbon, hydrogen and oxygen are not written together, they are separately written. So I will first convert them to writing the number of atoms they have together. Like for C, altogether 1 and 1, 2. For H, 3 and 1 is 4. And for O, it is 2. So now we can proceed to write its empirical formula, which is all divided by 2. So C, then H will become 2 and O. So this is the way we will be using to write the empirical formula, which we will require in many of the numericals coming ahead. Now in question number 2, 3 and 4, we will be seeing the calculation of finding the percentage composition of the elements or any particular compound in a particular compound which is there. So let us take a look at numerical number 2. Find the percentage of water of crystallization. It means in the formula you can see 5H2O, the percentage of this. In CuSO4 5H2O, atomic masses are given to us. And important thing to note here, atomic mass of copper is given as 64. Okay, hydrogen is 1, oxygen 16 and sulfur 32. So to know it, first of all, we should find the molecular weight of this entire compound CuSO4 5H2O. So we will calculate that first. So copper, it is given to us as 64 plus sulfur is 32 plus oxygen is 16 and 16 fours is 64. So I write here directly 64. 5H2O. For water, you know it comes as 18 because hydrogen is 1 into 2 is 2, and for oxygen 16. 16 plus 2 gives you 18. 18 multiplied with 5 gives you 90. So now we need to add all of them. 4 and 4, 8 and 2 is 10. 0, 1 carry 10, 16, 19 and 6 is 250. So this 250 we are getting as the molecular weight of CuSO4 5H2O. We need to find the water of percentage for water of crystallization. So we write the percentage composition formula, which is here in this case weight of water, because we have to find its percentage composition, then the molecular weight into 100. So here the molecular weight of water you can see is this entire part. So 90 comes here by the total weight which you have got as 250 and then into 100. So this 0 cancelled, 25 4s, so you get it as 36%. So this is the way to find the percentage composition of whichever element or water of crystallization which is asked. Now let us come to question number 3. In question number 3, it says calculate the percentage of phosphorus that is in calcium hydrogen phosphate. So first the process will be the same. We will go to find the molecular weight of it. So molecular weight of Ca H2 PO4 and then 2. So we are going to write here for calcium it is 40 the bracket, Hydrogen, it is 1. 1 into 2 will become 2. For phosphorus, it is 31 plus oxygen 16, it is there. 16 4 is 64, and then that entire thing multiplied with 2. So you get 40 plus 64 and 31 is 95. 95 and 2 is 97 into 2. So you get it here as 40 plus 2 sevens are 14, 2 nines are 18, 194. So this is coming to total as 234. Okay. Now we are asked percentage of phosphorus is told. So percentage of phosphorus equals to weight of phosphorus by molecular weight of the compound which is there into 100. So weight here we are getting it as for phosphorus. Take a look. This was of phosphorus. 31 multiplied with 2 will give you 62 by 234 and then into 100. So looking into this part of calculation, a very lengthy calculation is there. Okay, so you will have to work out this. So on doing it and calculating it, okay, I am getting here as 26.49%, which I can write it as 26.5%. Okay, so this finishes these two numericals. We will proceed to the fourth one now. So we proceed now to numerical number 4, which says calculate the percentage composition of potassium chlorate KClO3, which means we need to find the percentage of each of the elements present over there. So we go to find the molecular weight of it first. So potassium is 39 plus 35.5 and oxygen is 16. 16 3 is 48. So first of all 0.5, 8, 5, 13, 13 and 9 will give you 22, 2 carry, 6, 3 is 9, 9 and 3 is 12. So this you get as the molecular weight of KClO3. Now percentage of potassium will be equal to weight of potassium, which is 39 by 122.5 into 100. So that will be a result of a long calculation. We get the answer as this, 31.83%. Now moving to percentage of chlorine. Next is chlorine. So Cl, we get it as 35.5 by 122.5 into 100. So let us 28.98%. Now for percentage of oxygen, we get it, oxygen we are getting here as 48 by 122.5 into 100 as 39.18%. So this finishes this numerical, and you can see a big calculation has come over here. So keep practicing the calculation part so you get accurate answer. As such, in the last one we could have also done 100 minus the sum of these two and do it. So now let's see numerical number 5, which is actually of making the empirical formula. Question is like this: find the empirical formula of the compound with the following percentage composition. Lead is 62.5%, nitrogen 8.5%, oxygen is 29%. So this table is compulsory for doing such numericals. It gets it done easily with the help of this table. The contents of the table are the element, where you will be writing the elements given in the question, which is lead, nitrogen and oxygen. Then comes percentage composition. You will write the percentage of each of them. Lead is 62.5%, nitrogen is 8.5%, oxygen is 29%. Then you write the atomic mass of them. Lead is 207, nitrogen 14, oxygen 16. Now comes the main part, finding the atomic ratio. Now atomic ratio for lead will be this percentage divided by its atomic mass which is there. Dividing it, you are getting 0.3. You can write only up to one place of decimal. Nitrogen is 8.5 divided by 14, you get 0.6. And then oxygen is 29 divided by 16, you get 1.8. Once you have got this ratio, next column is of simplest ratio. What you have to do there is this. Out of these three, the one which is the lowest ratio has to be taken, and each of these ratio will be divided by that lowest value which is there of the atomic ratio. So 0.3 is the lowest, so 0.3 divided by the lowest 0.3, you get it 1. 0.6 divided by the lowest 0.3, you get it 2. And 1.8 divided by the lowest value is giving you 0.3 gives you 6. Once you have done this, now empirical formula can be written. So empirical formula, lead is Pb is 1, so we don't write that 1. Nitrogen is 2, so you write here N2, and oxygen is 6, so you write here O6. Because N2 and N and O are 2 and 6, which can be written as Pb NO3 whole 2, and so it becomes lead nitrate. So this is the way you will work out whenever you have to find the empirical formula. The table is a must, and find atomic ratio, find the simplest ratio and write it in this way. Question number 6 tells us this. Calculate the mass of iron in 10 kg of iron ore. So there is 10 kg of iron ore which contains 80% pure ferric oxide. So out in that iron ore, only 80% is ferric oxide. In that, how much of iron is there we have to find. So first of all, we will try to know how much of ferric oxide is there in 10 kg. So let us see. So we will find here quantity of ferric oxide is Fe2O3 in 10 kg of iron ore, which will be equal to, it is given 80%, so 80 by 100 into 10, which on calculation will give you 8 kg. So we have 8 kg of ferric oxide. We need to know how much of iron is there in it. So we will go to find the molecular weight of ferric oxide, Fe2O3. So iron is 56 into 2, oxygen is 16 into 3, 112 plus 48, that gives you 160, okay, in gram. So it means if I have got 160 gram of ferric oxide, in that the iron part is 112. So I have to know in 8 kg how much will be there. So I have to write here 160 gram of Fe2O3 contains 112 gram of iron. तो अब हम फाइंड करेंगे कि 8 kg में कितना है. 8 kg of Fe2O3 contains 112. For 1 gram it or 1 kg it will be by 160, and for 8 kg it will be into 8. So let us reduce it. 20, 2 10s are 256 are. So 56 by 10 will give us 5.6, because this was in kg. So I will write here kg of iron. This finishes this sum. Hope you have understood it. So let's follow numerical number 7, which says the empirical formula of two compounds is CH. So there are two compounds, their empirical formula is CH, single carbon, single hydrogen. And their vapor densities are 13 and 39 respectively. So vapor density is given to us. We have to find the molecular formula. So see how we will be working it out. So first, the first compound, So empirical formula, I am writing it as short E dot F is CH. So I should know now the empirical formula weight. So carbon is 12, hydrogen is 1, you get it as 13. Okay. So once I know the empirical formula weight, I will go to find the molecular weight by using that vapor density into 2 gives us the molecular weight. So for the first one, it is 13. So 13 into 2. So that gives us 26. Now you need to go to find N, which is molecular weight divided by the empirical formula weight. So that will give you 26 divided by 13, that is 2. So now you know the value of N. So now the molecular formula will be equal to the empirical formula multiplied with N. So empirical formula is given as CH and that multiplied with 2. So that makes it as C2H2. That is the first compound, it is done. Same way we will be doing for the second compound. So empirical formula for the second compound is also given as CH. So we will get the empirical formula weight same. So I am directly writing 13. Then the molecular weight of this one, vapor density is different. Vapor density mentioned here is 39. So 39 into 2, that will give us 78. So N by using the same formula, so no need of writing the formula again. 78 is the molecular weight divided by the empirical formula weight 13. So you know it comes as 6. So now molecular formula will be following the same formula. So we have the empirical formula as CH and then here N is 6. So I get it as C6. H6 is your answer. So this is the molecular formula. For the first compound is C2H2 and for the second one is C6H6. In question number 8, we have another sum based on finding of the empirical formula. So the question is, find the empirical formula of a compound containing 17.64% of hydrogen and 82.35% of nitrogen. So again, that table is important. So this top headings with the table is ready. Element, we have hydrogen and nitrogen. Percentage composition given 17.64% and 82.35%. Hydrogen has atomic mass 1 and nitrogen has atomic mass 14. Now the working starts actually. 17.64, the percentage divided by the atomic mass 1 gives you 17.64. For nitrogen, 82.35% divided by 14, a big division giving you 5.88. So now we need to find the simplest ratio. Out of the two, this is the smaller one. So both of these will be divided by the smaller one. So you have 17.64 divided by 5.88. When you are finding the simplest ratio, simply take rounded off values and divide and get it in terms of a whole number. So I am considering 17.64 as 18 and 5.88 as 6. So 18 divided by 6 gives you 3. And here both of them are same, so you get it as 1. So now we go to write the empirical formula. So empirical formula, hydrogen is 3 and nitrogen is 1. So we write for nitrogen first, N is 1, hydrogen is 3. So you get this empirical formula and you know this compound is ammonia, which is it's actually the molecular formula also. So this finishes this sum. So it's all about getting your table correctly done and the sum becomes very easy. So let's follow what question number 9 tells us. On analysis, a substance was found to contain carbon 54.54%, hydrogen 9.09%, oxygen 36.36%. The vapor density of the substance is given to us 44. We are asked to calculate its empirical formula as well as molecular formula. So because empirical formula is there, so the solution will contain the table. So I have given the table ready, but follow the explanation. The three elements here are carbon, hydrogen, oxygen, and their percentage given as 54.54% and 9.09% and 36.36%. Okay. Atomic masses are mentioned here. For carbon 12, hydrogen here, oxygen 16. Now comes the main process. We have to find the atomic ratio. So whatever is the percentage composition divided by the atomic mass, that is giving us 4.5. 9.09 divided by 1 will give us 9.09, and 36.36 divided by 16 will give us 2.27. So this part will require little bit of calculation of dividing. Now once we have got here, we take a look: 4.5, 9.09, 2.27. So the least one is 2.27. So while finding the simplest ratio, each one of these will be divided by the lowest one, which is 2.27. So dividing 4.5 with 2.27, you get it 2. Dividing 9.09 with 2.27, you get it 4. Now see, when you are dividing this also, because we need whole number, we can take a rough work value. So 9, I can take this, and this one I can take it as 2.3. And if you divide 9 with 2.3, you will come close to 4. So we write the whole number part 4. Same way 4.5 is nearly the double of 2.27. Then 2.27 divided by 1 gives us the simplest one, a ratio as in terms of 2, 4 and 1. So we can go to write the empirical formula now, which will be, empirical formula will be C is 2, H is 4 and oxygen is 1. So we don't write. So empirical formula part is done. We have to find the molecular formula also. Now because we have the vapor density given to us as 44, so we will go to calculate the molecular weight, or to say the molecular mass, which is Vd into 2. So that is 44 into 2 is equal to 88. We also need the empirical formula weight or mass. So this I will get it from here. Carbon is 12 into 2 plus hydrogen is 1 into 4 plus oxygen is 16. So from here 24 and 16 makes it 40 and 4 makes it 44. So now we will go to find the value of N, which is molecular mass by empirical formula mass. So that will give us 88 by 44, that is equals to 2. So now we come to the molecular formula. So which is the empirical formula multiplied with N, which in this case is 2. So we have here empirical formula as C2H4O and now 2 here. So we will multiply with 2 all of them and we get it as C4H8O2. So this is your molecular formula. So this way this sum is solved, where you had to form the empirical formula as well as the molecular formula. Now to numerical number 10, the question is like this: an organic compound whose vapor density is 45 has the following percentage composition: hydrogen given 2.22%, oxygen given 71.19%, and remaining is carbon, which we need to calculate it out. So I have written the three elements: hydrogen and oxygen and carbon. Hydrogen percentage is given there 2.22%, oxygen is also given 71.99%. Okay, then we calculate the carbon percentage, which is 25.79%. How do we get 100 minus 2.22 minus 71.99? And we get the percentage for carbon. Then the atomic masses are written here. Okay, and now we go to find the ratio. So for hydrogen, 2.22 divided by 1 gives you 2.2. For oxygen, 71.99 divided by 16 gives you 4.4, and for carbon 25.79 divided by 12 gives you 2.22. So we know that the smallest ratio is 2.2 at two places. Now to find the simplest ratio, we go to write the values here. So it will be 2.22 divided by 2.22. So that will come as 1. For oxygen, you will get divided by 2.2, which will give you 2 here. And for carbon, it is 2.2 divided by 2.2. So you get it as 1. So now we know the ratios over here. So we can go to find the empirical formula. So which will be H is 1, O is 2, and C is 1. So we will just write in an order the way we write the compounds, especially organic compounds. So it comes as CHO2. Now we have to also find the molecular formula. Okay, so the molecular formula finding will go like this. We go to find the empirical formula weight, which we will be needing it. So empirical formula weight, which will be 12 here plus 1 plus 16 into 2. So 16 into 2 is 32, 33, 33, 35, 45. So we get it as 45. Then molecular weight we will find by using vapor density into 2. So vapor density is given to us as 45. So 45 into 2, which gives us 90. So we have come to know the empirical formula weight and molecular weight. So our next part is to get the value of N, molecular weight, divided by the empirical formula weight, which gives us 90 by 45 is equals to 2. So I go to find the molecular formula now. So molecular formula will be empirical formula, which came as CHO2, and that multiplied with N, which came as 2. So that gives us C2H2O4. So this is the molecular formula of it. So it was similar to the last sum. Okay, we will get a lot of sums like this where it will be empirical formula to be found and then molecular formula to be calculated, and it will always go in the same way only. So now we come to question number 11, which is also a sum where you will be finding empirical formula and molecular formula, a type of sum which we have already done. An organic compound contains 4.07% hydrogen, 71.65% chlorine and remaining carbon. मोलर मास इज 98.96, मतलब मोलिकुलर मास दिया हुआ है. फाइंड इट्स एम्पिरिकल फॉर्मूला और मोलिकुलर फॉर्मूला फाइंड करना है. तो सबसे पहले हम परसेंटेज ऑफ कार्बन निकाल लिए. ओके, 100 माइनस हाइड्रोजन का परसेंटेज माइनस क्लोरीन का परसेंटेज, सॉल्व करके 24.28 आया. तो अब हम सब एलिमेंट लिख करके इनका परसेंटेजेस लिख दिए हैं, एटॉमिक मासेस भी लिख दिए. अब हम लोग एटॉमिक रेशियो फाइंड करने जाएंगे. तो इसका हो गया 4.7 बाई 1, 4.07 आ गया. क्लोरीन का 71.65 को उसका एटॉमिक मास से डिवाइड करो 31.5 से, तो वो तुमको यहाँ पर मिल गया है 2.01. कार्बन का 24.28 को उसका एटॉमिक मास से डिवाइड करो तो मिलता है डिवाइड करके 2.02. अब सब में अगर देखेंगे तो 2.01 सबसे छोटा है, बहुत ही सब क्लोज टू 2 और 4 है, इसलिए हम इसका राउंडेड ऑफ वैल्यू ले करके ही कॉमन सिंपलेस्ट रेशियो फाइंड करेंगे. तो सबसे लोवेस्ट 2 है, तो हाइड्रोजन का इसमें 4 डिवाइडेड बाई 2 लिए 2 आ गया, क्लोरीन का इसमें 2 बाई 2 लिए 1 आ गया, और कार्बन का इसमें 2 बाई 2 लिए 1 आ गया. तो अभी हम लोग एम्पिरिकल फॉर्मूला लिख सकते हैं. जो एम्पिरिकल फॉर्मूला आ जाएगा वो आ जाएगा C 1 है, Cl 1 है और H2 है, तो उसको हम लिख देते हैं CH2Cl. ये एम्पिरिकल फॉर्मूला हो गया. तो इसका पहला वाला पार्ट का आंसर यहाँ पर हो गया. अब बी वाला पार्ट मॉलिक्यूलर फॉर्मूला निकालने के लिए सबसे पहले निकालने जाओ एम्पिरिकल फॉर्मूला वेट। तो ये हो गया कार्बन का 12, हाइड्रोजन का 1 × 2 और क्लोरीन का 35.5। तो सबको अगर हम ऐड करते हैं 2 और 8 12 हो गया 14, 14 को हम 35 से ऐड करते हैं तो 49.5 आ जाएगा। तो अब एम्पिरिकल फॉर्मूला वेट हो गया, मोलर मास हम लोगों को दिया हुआ है 98.96, तो हम लिखेंगे मोलिकुलर वेट लिख लो 98.96। तो अब हम लोग n का वैल्यू निकाल सकते हैं, n इज मोलिकुलर वेट डिवाइडेड बाय एम्पिरिकल फॉर्मूला वेट। तो 98.96 डिवाइडेड बाय 49.5। तो n जो है हमेशा ही वो होल नंबर में आएगा, तो एक क्लोजेस्ट होल नंबर इसको डिवाइड करके देख लो, मिलेगा 98 और 49 है, 49 2 × 98 होता है, तो हमने उतना ही देख के 2 लिख दिए। अब हम लिख सकते हैं मॉलिक्यूलर फॉर्मूला इक्वल्स टू, जो एम्पिरिकल फॉर्मूला है, एम्पिरिकल फॉर्मूला था CH2Cl, उसको मल्टीप्लाई करेंगे n का वैल्यू दैट इज 2 से, तो ये बन गया C2H4 और Cl2। तो ये आ गया मॉलिक्यूलर फॉर्मूला। नाउ लेट अस कम टू न्यूमेरिकल नंबर 12 which is slightly different. So take a look and understand what it says. A hydrocarbon, so a compound with carbon and hydrogen only, contains 4.8 gram of carbon per gram of hydrogen. So here it is told that if you take 1 gram of hydrogen, it will have with it 4.8 gram of carbon. So here the masses which are present in the element are told, it is not told in terms of percentage. So we can take that value also and solve it. Okay. Calculate the gram atom of each. We have to find the gram atom of each. Okay. Which is the same as this atomic ratio. Okay. Find the empirical formula and then the molecular formula if its vapor density is 29. Main thing is how to relate this part. So it is 4.8 gram of carbon per gram of hydrogen. So for hydrogen, I am taking here as 1 gram. Okay, the composition says it is 1, so 1 gram. And carbon is then 4.8 gram as shown over there. Atomic mass is written. Now, atomic ratio. So atomic ratio, mass of it divided by its atomic mass. So 1 by 1 will give you 1. So I have written there 1. And for carbon, 4.8 gram divided by 12 give its gram atom, that is 0.4. So A part answer is gram atom of hydrogen, that is 1, and gram atom of carbon is 0.4. That we have got. So now we will go to find the empirical formula. So for that, atomic ratio we have got 1 and 0.4. So 0.4 is the smallest one. So dividing 1 with 0.4 we get 2.5. Now we are getting exactly 2.5. So you cannot go to 3 or you cannot come back to 2. So what has to be done, we will see to it. 0.4 divided by 0.4 is 1. So what we do is to go to the whole number part, we multiply with 2 here as well as here, so that it will become a whole number. So this multiplied by 2, so this becomes 5 and this becomes 2. So now our molecular formula will be, empirical formula will be based on this one. So it will become C2 and H5. Okay, so this is our empirical formula. Now we come to the C part, which is the molecular formula part. So using the empirical formula, I will find the empirical formula weight, which is 2 into 12 plus 5 into 1, so 24, and here 5 is 29. What is provided to us is the vapor density. So we will need to find the molecular weight using the vapor density formula, which is Vd into 2, so that is 29 into 2 becomes 58. Now we can go to find n value, molecular weight by empirical formula weight, which gives us 58 divided by 29 equals to 2. So now you write the molecular formula as the empirical formula, which was C2H5 multiplied with this n value, which came as 2. So you get the compound C4H10. So this is what is done. So you have to remember how the masses were given I had taken, and also regarding when you get exactly in 0.5, this is the procedure you have to do, multiply with 2 to make it a whole number, and 2 multiplication with both it has to be done. तो अब हम क्वेश्चन नंबर 13 देखते हैं। ये थोड़ा सा इंफॉर्मेशन जो पहले सम्स में आ रहा था इसमें थोड़ा डिफरेंस है, तो गौर करो कि किस तरह का डिफरेंस है और ऐसा डिफरेंस रहने से सम्स को किस वे से करेंगे। तो 0.2 ग्राम एटम ऑफ सिलिकॉन कंबाइंस विथ 21.3 ग्राम ऑफ क्लोरीन, फाइंड द एम्पिरिकल फॉर्मूला ऑफ द कंपाउंड। तो गौर किया क्या डिफरेंस है इसमें? तो देखो डिफरेंस क्या है। ये जो इंफॉर्मेशन सिलिकॉन के बारे में है 1 ग्राम एटम में दिया हुआ है, 1 ग्राम या परसेंटेज में नहीं दिया ना। तो इसके पहले सब सम्स में या तो इंफॉर्मेशन ग्राम में रहता था या फिर परसेंटेज में रहता रहा। तो सिलिकॉन के ग्राम एटम में दिया, और हर एक सम्स में हम लोग टेबल में ग्राम एटम फाइंड करते हैं जो एटॉमिक रेशियो होता है। तो इसीलिए हम सीधा इसको यहाँ पर 0.2 लिख दिए हैं एटॉमिक रेशियो में। आगे क्लोरीन का इंफॉर्मेशन तो ग्राम में है, इसलिए उसको कंपोजिशन में ग्राम में लिख दिए। एटॉमिक मास है 35.5, तो 21.3 को 35.5 से डिवाइड करो, उसका ग्राम एटम मिल गया, मतलब एटॉमिक रेशियो मिल गया 0.6। अब हमको सिंपलेस्ट रेशियो फाइंड करना है, तो दोनों में छोटा 0.2 है, तो सिलिकॉन का आ गया 0.2 बाई 0.2 1 आ गया, और क्लोरीन का आ गया 0.6 डिवाइडेड बाई 0.2 3 आ गया। तो हम लोग को सिर्फ यहाँ पूछा है एम्पिरिकल फॉर्मूला, तो एम्पिरिकल फॉर्मूला हो जाएगा इसका सिलिकॉन का कुछ नहीं, सिर्फ 1 है तो नहीं लिखेंगे, और Cl का 3 है। ये सम्स बन गया इस तरह से। तो इसका खरी यही इंफॉर्मेशन जानना था कि ये ग्राम एटम में दिया हुआ था, तो इसको कहाँ पुट करना है। अब हम देखते हैं कि क्वेश्चन नंबर 14 क्या बोल रहा है। क्वेश्चन नंबर 14 बोलता है गैसेस हाइड्रोकार्बन, तो हाइड्रोकार्बन कार्बन और हाइड्रोजन सिर्फ होगा, कंटेन्स 82.76% कार्बन का परसेंटेज दे दिया है, गिवन दैट इट्स वेपर डेंसिटी इज 29, फाइंड इट्स मोलिकुलर फॉर्मूला। तो इस तरह का न्यूमेरिकल हम लोग पहले भी कर चुका है, इसलिए इसको हम सॉल्व नहीं करेंगे, थोड़ा खरी इंफॉर्मेशन दे देंगे। कार्बन का जगह 82.76% लिखना है कंपोजिशन का जगह पे, ठीक है। और हमको हाइड्रोजन का नहीं दिया हुआ है, तो हाइड्रोजन का परसेंटेज निकलेगा 100 माइनस दिस, क्योंकि हाइड्रोकार्बन में सिर्फ कार्बन और हाइड्रोजन होता है, तो उसको माइनस करके निकल जाएगा। फिर सेम प्रोसीजर जैसे हम लोग आगे सब में किए हैं, एम्पिरिकल फॉर्मूला निकालो, उससे एम्पिरिकल फॉर्मूला वेट निकालो। वेपर डेंसिटी 29 दिया है तो मोलिकुलर वेट 58 हो जाएगा, इंटू 2 29 इंटू 2 करके फिर n का वैल्यू निकालो और फिर मोलिकुलर फॉर्मूला निकाल लो। तो इसलिए इस सम्स को अपने से सॉल्व कर लो, सेम रिपीटेड टाइप है इसलिए हम नहीं कर रहे हैं। तो आओ चलो देखते हैं क्वेश्चन नंबर 15। देखने में सम्स बहुत ही लंबा है लेकिन बहुत ही इजी सम्स है। ये पहले भी हम लोग इस तरह का सम्स कर चुके हैं। तो चलो देखते हैं क्वेश्चन क्या बोल रहा है। इन अ कंपाउंड ऑफ मैग्नीशियम, मैग्नीशियम का एटॉमिक मास 24 दे दिया हुआ है, एंड नाइट्रोजन उसका भी एटॉमिक मास 14 दे दिया हुआ है। बोल रहा है 18 ग्राम ऑफ मैग्नीशियम कंबाइंस विद 7 ग्राम ऑफ नाइट्रोजन, मतलब जो कंपाउंड है उसमें मैग्नीशियम का क्वांटिटी 18 ग्राम है और नाइट्रोजन का 7 ग्राम है। तो बोल रहा है डिड्यूस द सिंपलेस्ट फॉर्मूला बाय आंसरिंग द फॉलोइंग क्वेश्चंस। तो एक एक चीज पूछा। ए पार्ट में पूछा हाउ मेनी ग्राम एटम्स ऑफ मैग्नीशियम आर इक्वल टू 18 ग्राम, मतलब 18 ग्राम को ग्राम एटम में बदलो। ऑलरेडी पहले सब में देख चुका है, एक ग्राम एटम वही है जो एटॉमिक रेशियो निकलेगा। फिर हाउ मेनी ग्राम एटम्स ऑफ नाइट्रोजन आर इक्वल टू 7 ग्राम ऑफ नाइट्रोजन, तो 7 ग्राम नाइट्रोजन का भी ग्राम एटम निकालना, जो एटॉमिक रेशियो का आंसर आएगा वही रहेगा। फिर सी में पूछ रहा है कैलकुलेट द सिंपल रेशियो ऑफ ग्राम एटम्स ऑफ मैग्नीशियम टू ग्राम एटम्स ऑफ नाइट्रोजन, तो सिंपलेस्ट रेशियो वाला पार्ट में निकलेगा वो चीज। और फिर hence the simplest formula of the compound formed, उसके बाद हम लोगों को empirical formula निकालना है। तो चलो टेबल में फॉलो करो, मैग्नीशियम लिख दिए, नाइट्रोजन लिख दिए, जो एलिमेंट है कंपाउंड में। कंपोजिशन मैग्नीशियम का 18 ग्राम दिया था, नाइट्रोजन का 7 ग्राम, उनों का एटॉमिक मास हम लोग को बता दिए थे, उसको लिखे। तो अब एटॉमिक रेशियो जो ग्राम एटम है, तो पहले वाला का आंसर जो ग्राम एटम मैग्नीशियम का पूछा है, तो हम लोग लिखेंगे ग्राम एटम ऑफ मैग्नीशियम। तो कैसे निकलता है, जितना भी उसका मास है उसका एटॉमिक मास से डिवाइड करो, 18 को 24 से डिवाइड करो, तो 0.75 ग्राम एटम्स हो गया। ठीक है। इसी तरह से बी में पूछा है ग्राम एटम्स ऑफ नाइट्रोजन पूछा है 7 ग्राम में, तो ग्राम एटम ऑफ नाइट्रोजन बिकम्स 7 को 14 से डिवाइड करो, 0.5 आता है, तो 0.5 आ गया। तो ये बी और सी, ए और बी का पार्ट हो गया। अब सी को देखते हैं, तो इसमें सिंपलेस्ट रेशियो निकालना है, तो सिंपलेस्ट रेशियो जो है ये तुम्हारा 1.5 इंटू 1 आया है, लेकिन 1.5 में नहीं रखना है, ये हम लोग सीखे हैं। तो हम लोग यहाँ पर क्या करेंगे, इसको इंटू 2 करेगा तो ये 3 हो जाएगा, तो यहाँ भी इंटू 2 करो, ये 1 हो जाएगा। ठीक है। तो इसका मतलब मैग्नीशियम और नाइट्रोजन का जो सिंपलेस्ट रेशियो है वो 3:1 है। तो हम लोग को पूछा है, तो इसलिए हम लोग उसको लिखेंगे सिंपलेस्ट रेशियो ऑफ मैग्नीशियम एंड नाइट्रोजन इज इक्वल टू 3:1। तो उसको डेसिमल में नहीं लिखना है, ठीक है, होल नंबर रेशियो होना है। अब हम लोग को पूछा है कि उसका एम्पिरिकल फॉर्मूला बताना है, तो सिंपलेस्ट रेशियो से ही एम्पिरिकल फॉर्मूला रहता है। तो mg का 3 आया और नाइट्रोजन का 2 आया, तो ये मैग्नीशियम नाइट्राइड हो गया। इस तरह से न्यूमेरिकल हो गया खत्म। तो जो थोड़ा डिफरेंस था, वो डिफरेंस को पकड़ो कि डेसिमल में जब आता है ठीक 0.5 में, तो उसको कैसे किया जाता है। So let us now come to numerical number 16, which says barium chloride crystals contain 14.8% water of crystallization. Means if you are having barium chloride, with it 14.8% water of crystallization is there, means water molecules are there. Find the number of molecules of water of crystallization per molecule. It means if you have 1 molecule of barium chloride, then it will have how many molecules of water. So it is a empirical formula type sums only, because we have to find the simplest ratio, and the simplest ratio for barium chloride is 1. So I need to keep barium chloride 1 and then see how many water of crystallization I am going to get. So first of all, barium chloride molecular mass has to be known. So 137 is the atomic mass of it. Chlorine is 35.5 into 2. On solving it out, you are getting 208. So here it's not element, it should be compound, barium chloride and water written. Composition of water was given to us 4.8. The other one is barium chloride, so 85.2 written. Molecular mass of barium chloride is 208 and of water it is 18. Okay, so now atomic ratio, that is actually the molecular ratio. So 85.2 divided by 208, you will get 0.4, and then 14.8 divided by 18 gives you for water as 0.8. Now we go to find the simplest ratio. So simplest ratio, the lower one is 0.4 out of the two. 0.4 divided by 0.4 is 1, and 0.8 divided by 0.4 is 2. So now you see barium chloride is 1 and water is 2. It means per molecule of barium chloride, number of molecules of water will be 2. So that gives you the answer for it, which we will write it here. So we will write number of water molecule per molecule of barium chloride is equal to 2. Okay, so that finishes this sum. Let us take a look at the 17th one. A hydride of nitrogen contains 87.5% by mass of nitrogen. So hydride of nitrogen means you have the element only nitrogen and hydrogen there, out of which 87.5% is nitrogen. So 100 minus 87.5, which is 12.5, will be your hydrogen. Determine the empirical formula of this compound. So only two elements. We have seen earlier several sums where two elements were there. Percentage of one of them was given, and how did we found the empirical formula as well as the molecular formula. So try out this sum on your own, and if you have any problem, you can write into the comment and ask me. I will answer you there. Now coming to question number 18. Determine the formula of organic compound if its molecule contains 12 atoms of carbon. So we have to get the formula, means the molecular formula, and carbon should be there 12. Okay. The percentage composition of hydrogen and oxygen are 6.48 and 51.42. So we will have to find out the percentage of carbon which is there. So that we can get it as we have done in the earlier numericals. 100 minus 6.48 minus 51.42. So that part I have calculated and written the percentage. Hydrogen given as 64.48, oxygen 51.2. So 100 minus the sum of these two gives me 42.1. Atomic masses of hydrogen 1, oxygen 16, carbon 12. So we go to find the atomic ratio. Atomic ratio 6.48 divided by 1 gives you 6.48. 51.42 divided by 16 giving you 3.21, and 42.1 divided by 12 giving you 3.5. So once we know the atomic ratio, you know we have to find the simplest ratio. Smallest one is 3.21. Dividing each one of them with 3.21, we get hydrogen as 2, oxygen as 1, and carbon as 1. So I can go to write first of all the empirical formula. So C is 1, H is 2, and O is 1. This is the empirical formula. But what is told? Carbon should be 12. So to get the molecular formula, because carbon is 1 here and it is required to be 12, we get N value as 12. So it means that empirical formula CH2O needs to be multiplied with 12 to make carbon 12, and the necessary changes will take in the others also. So you get C is 12, H24 and O12. This becomes the molecular formula of the organic compound which was asked there. Now let us see what numerical number 19 has to say. It has got three parts A, B, C. We will look at them individually. Starting with 19A, a compound with empirical formula AB2 is the empirical formula told, has the vapor density equal to its empirical formula weight. So whatever is the empirical formula weight, vapor density is the same. So we are asked to find its molecular formula. So what we will do here, we will consider that let empirical formula weight is equals to X, and vapor density is also equal to that. So vapor density also becomes X. So now we will get molecular weight is equals to vapor density into 2, that is X into 2 equals to 2X. So now we know the molecular formula weight as well as the empirical formula weight. So let us calculate N, molecular weight by empirical formula weight. So that is 2X by X, that is equals to 2. Empirical formula here is given to us as AB2. So molecular formula will become the empirical formula AB2 multiplied with this n value 2. So that makes it A2B4. So this was your sum number 19A. Now let us take a look at 19B. A compound with empirical formula AB has vapor density 3 times the empirical formula weight. Find the molecular formula. So is this sum similar to this part? So I leave it for you to work it on your own and get the result. Now let us see the C part. So we will come up with this C part by getting the necessary table drawn. You can see here what it says. 10.47 gram of a compound contained 6.25 gram of metal A, and then the rest is the non-metal B. Calculate the empirical formula of that compound. Atomic weight A and is given as 207 and B is given as 35.5. So let us draw the table and do it. The table for numerical part C of this is ready. Again, I go through the question. 10.47 gram of the compound was there. 6.25 gram of metal A. So A composition 6.25. 10.47 was the entire compound mass. So 10.47 minus 6.25 will give you 4.22. Atomic masses which were given 207 and 35.5 written. When to find the atomic ratio, 6.25 by 207, 0.03 came. 4.22 divided by 35.5 comes as 0.11. Now we go to find the simplest ratio. This is the lowest one. So dividing will come 1 there. 0.11 divided with 0.03 comes as 3.6, which we are going to make it as 4 because we need a whole number ratio. So now A is 1 part, B is 4 part. We are asked to find the empirical formula. So empirical formula, A is 1 and B is 4. So it becomes AB4 and the C numerical is done. So now finally to the last numerical of this topic, which is question number 20. It says the compound has oxygen 61.32%, sulfur 11.15%, hydrogen 4.88%, zinc is 22.65%. The relative molecular mass is given as 287 AMU. Find the molecular formula of the compound, assuming that all the hydrogen is present as water of crystallization. So all the hydrogen goes to that water of crystallization. This is a very important part to be understood. So let us take a look into all the things in the table. I have written here all the elements which are present, their percentage composition which is given in the question, and then the atomic masses. We need to find the atomic ratio as we have been doing in all the sums. So finding the atomic ratio, you know how to find it. For oxygen it comes to 3.8, sulfur is 0.34, hydrogen is 4.88 and zinc is coming as 0.34. So the lowest one is 0.34. When you divide 3.8 with 0.34, you get it as 11 point something. As a whole number, we write it 11. 0.34 divided by 0.341. 4.88 you divide it with 0.34, rounded off gives you 14. And here it comes to as 1. Now we know the empirical formula we can get. So I would like to write Zn first, which is 1. Then I will go to write sulfur, which is 1. Oxygen then I will write, which is 11. And then hydrogen is 14. We should know the empirical formula mass. So that will be equal to Zn is 65 plus sulfur is 32. Oxygen is 16. So 16 into 11 is 176. Hydrogen is 1 into 14 is 14. So if you add it up, 6, 4, 10, 12 and 5 is 17. 1 is carried over, 2 and 17, 19 and 3, 22 plus 6 is 287. So we know the empirical formula mass. Let us find N value. molecular mass by empirical formula mass. So that will give us, it is given here 287. So here also 287 gives us 1. So molecular formula, because n is 1, we can say molecular formula is equals to the empirical formula. So first of all, I will write as what we had given there and then go to look for what the question said. The question tells here that the molecular formula of the compound, assuming that all the hydrogen is present as water of crystallization. How many hydrogen is there? 14. Water formula is H2O. So I am writing H2O. All the hydrogen goes in water. Here it is 2. So if I write here 7, it becomes 7 2s are 14. But the moment I write here 7 oxygen is also used. So from 11 of them, 7 is used up in water of crystallization. 4 are left. So this becomes ZnSO4.7H2O. So you get the solution of this one. With this, we have come to the end of this empirical formula. All the sums you saw are table based. The table format is very important to be remembered and a lot of calculations will come here. Okay, so practice them a lot and make it perfect. Hope my explanation has helped you all and it has made you to understand. Looking forward to coming up with the last part of this mole concept and stoichiometry chapter, which is based on chemical equations. Thank you for watching this video.